Okay, page 19 then. It says part 3, state 2 geometrical relationships. 2 geometrical relationships between RO and OM. So we better go back to the previous page, hadn't we? Between RO and OM. Here we go. Show that OM is equal to KRO. And K was 3, wasn't it? So if you look back at the sketch, there's RO. And there's OM. Now, it doesn't look like they're the same direction, does it? Because it's intentionally drawn like that, so you don't pick that up from the diagram. You have to pick up the information from the actual, this property here. So this vector is just a scalar multiple of this vector. That means they're heading in the same direction, because it's positive. So they're both heading in the same direction, and one is 3 times the size of the other, because you multiply one by 3 to get to the other. Yeah? So I think that's the 2 things to say then, that they're in the parallel, and they form a straight line, and one is the smaller one is a third of the larger one. Okay, so which one was the smaller one? OR was the smaller one, wasn't it? Yeah. So let's put that down on the next page then. So we got 2 geometrical relationships. Well, they're parallel. The 2 lines OR and OM are, well, it says between RO and OM. So I better look a bit more carefully at that, hadn't I? Because let's just see RO and OM. So let's look back. RO and OM. Yep. R to O and O to M. Good. They're parallel, and they're in the same. Form a straight line. So RO is parallel to OM, and they form a straight line. A straight line. I think that's good enough there. And the other thing to say is that one is 3 times the other, or one is a third of the other. So the RO part is 1/3, isn't it? Third of the length of the other one, which was OM. Yeah? Because we said that, because we got scalar multiple of 3, wasn't it? So one is 1/3 of the other. Or this is 3 times that. It's the same thing. Okay then, that's part 3 done then. Good, that finishes that question. Let's go down to 13 without further ado. We've got a triangle which is not right angled, so straight away we say it's going to be either the sine rule or the cosine rule. So without thinking about it at all, we just so what I would do is I would write down the sine rule straight away. A over sine A equals B over sine B. Right at the outset. I haven't even read the question yet. So that's what I put, because hopefully I can use that, and if I can't use that, then I've got to go to the cosine rule, haven't we? So calculate the size of the angle CAB. So this is the angle C, so this is the side C. This is the angle A, so this would be the side A. This is the angle B, so this would be the side B. Now I'm going to tick off what I've got in this. So I've got A, so I can tick that one off, can't I? I've got angle C, so I can tick this thing off. I got side C, right? And have I got anything else? No, that's it. Now I need 3 of any 4. And when I say 3 of any 4, it needs to be 3 of any 4 of those, or 3 of any 4 of those, or 3 of any 4. Now you'll have to excuse me because I'm going to draw a convoluted shape here. But it's these 4. Alright? So you need 3 of any 4 of those arrangements. And I can see straight away that I've got that, and there's 3 of 4 in that one. So that's the joined up thing I want to do. 3 of any 4 in this pattern. Okay, so I'm going to use this part here, A over sine A equals the C over sine C, yeah? Because I got 3 of the 4 and I can find out the 4th thing. Now that's all I can do. So hopefully that will start to help me find out about the triangle and work out this answer here. So A, so let's overwrite A with 10.6. So I'm going to get a thicker pen, and instead of A, I'm going to put 10.6, and C is 11.7. So I got 11.7. Hope you can read that. And then the C angle was 61, so I'm going to put that here. Yeah, and that's degrees. So I need to be in degrees mode. So here I'm going to work out that number. Alright, so let's go back to normal. 10.6 over sine A. So let's just write that down. Okay. And I'm going to work out this number because we can do. We've got 11.7 over sine 61. So it's 11.7 divided by sine of 61 degrees. I'm in degrees mode still, so I've just checked that. So that's fine. So 11.7 divided by sine 61 equals, now I'm going to keep it nice and accurate here, 13.377. 13.377, that should do. So now we need to work out sine A, don't we? So let's move this from divide to times. So leave the 10.6 where it is, and then leave that where it is. And then we're moving the sine A from divide on one side to times on the other. So I need times sine A. So that's halfway there, isn't it? And then we can read off what sine A is, because move this from times to divide and read from right to left. So I can put sine A is equal to the 10.6, and that moves down underneath the 10.6. 377. Okay, so I got 10.6 divided by 13.377, and then I need to do a shift sign on that. So I got 10.6 divided by 13.377 equals 0.7924. I'm going to do that. 0.7924. And I'm going to keep it in the calculator because I can do shift sign. So A, this is the angle we've got, will be sine to the minus 1, shift sign undoes the sign, arc sign in other words, and you arc sign both sides, so it's shift sign 0.7924, that's what we put in the calculator. Let's do that then. Oops. Helps to get the right sheet coming up, doesn't it? So let's get the calculator. So what did we say? We said shift sign 0.7924, I think it was. 7924 bracket equals 52.41. Now we can round to 2 dp, 52.41. So 52.41 degrees. So A in our diagram, which is here, I can put down 52.41 now. Now I'm going to look back at the question. It says calculate the size of CAB. So that was good. It's 52.41. i.e. the angle, the way they've drawn it is CAB, like so. That's the angle A, isn't it? It's 52.41 degrees, so put that in at the end. Alright then. So we could round it off to 1 dp if we wanted. But I think that was to 2 dp, wasn't it? But probably better to do 52.4 to 1 dp. So let's do that, just to finish it off. Makes it look a bit better. 52.4, and that would be to 1 dp, wouldn't it? Yeah? Okay then. That's that one done. Good. Page 19's done then. Let's go on to the next one.